Hello everyone, welcome to Practical Mechanics. I'm Mohsen. Today's video, we learn how to calculate the centroid of a cross section. We see in calculation of bending stress, we need to locate the neutral axis. And we know that neutral axis passes through the centroid of the cross sections. Centroid for some cross sections are not easy as symmetric, for example, cross sections. If this cross section is symmetric, for example, like an I-beam, then you know that the centroid is in the middle intersection of symmetric axes for this beam. But what happens if we have a beam which has no symmetric cross sections, like T-beam? In T-beam, then the centroid will be different. It's not actually, there is no vertical, actually horizontal, actually symmetric axis, and you cannot find the centroid easily. In this case, we divide the cross section into simple geometric shape, like here, two rectangle, and find the centroid of each one just by intersection of diagonal or just by symmetry. We have this one here and this one here, these two centroid. We have to assume coordinate axis x and y and draw it. For example, this one here, x-axis and y-axis. Then, in that case, we know that the centroid always is on the symmetrical axis of symmetry, symmetrical axis. Then the centroid of this composite shape is on the y-axis. It means that its x bar that we show it means that x coordinate of the centroid, which is show it by x bar, is 0. It is located on the y-axis. But where? In order to find out, we must first find the coordinate y of each centroid. We called it this area A1, and centroid of it from origin O is y1, and centroid of the second one from the origin is y2. Because it shows the centroid of each area, we can show it by y bar with respect to O. Then, if we find the centroid, which is here, between these two centroids, must be between them, we can call it y bar, centroid of the whole cross section. Then there is always a balance. You know, the centroid is a point that you hang it. It just stay in balance, the object. Then here, the same as for surface. Then here we say that if it is in balance, means that these two areas, which this one is A1, this one is A2, A2 times y bar 2 plus A1 times y bar 1 is equal to A1 plus A2 times y bar. That's the meaning of centroid. Then y bar is equal to A1 bar, A2, A bar y2 divided by A1 plus A2. That's how to find the centroid distance when it is at neutral axis, at the axis of symmetry. In general form, y bar is equal to, maybe we have more than two objects, in this case, 3 objects, 4 objects. Then we use the Simple summation of all areas, AI, times their centroid from an origin. Origin is up to you, where you want to put it, the origin. You have to find it which location for origin of the coordinate is easier. Divided by summation of all areas. AI. That's a formula to calculate if we have a vertical axis symmetry, then we don't calculate x bar. But sometimes it happens that there is no symmetrical axis for symmetry. Axis is not symmetry. If I change it to this part, for example, assume that we have this shape. In this case, you can divide it into three simple geometric shape, and you have it. This is now you don't have no horizontal axis for symmetry, no vertical axis for symmetry. Then you can choose origin, for example, this corner. This is axis y, this is axis x, and for any centroid, you have x and y coordinate for any centroid. Here, this is y bar 1, this is a1, this is a2. Here, this is y bar 2, and here, this is y bar 3. And also for x coordinate from the y-axis, this is x bar 3, this is x bar 2, this is x bar 1. And you want to find the centroid. Coordinate of the centroid, assume is here, for example, is called x bar and y bar. We have to calculate both of them because you must locate it for the cross section to find out the neutral axis of the beam under bending, for example. Then in this case, like this formula for y bar and x bar, we say that, okay, summation of all areas time x bar I for each one divided by summation of all areas. Y bar the same, summation of all areas time y bar I divided by summation of areas, in this case. What happened if we have a cross section that is combined of is a hollow cross section like this one? You have a cross section like this. Then there is no axis of symmetry. You can assume y the origin here, and this is x. Then centroid of this circle is in here. You can call it a1, y bar 1, x bar 1, and this one we know it from a shape for the field object, semicircle. Then this is what? This is a semicircle minus a hole on that. Then first we consider the centroid of this, which is 4 radius divided by 3 pi, and centroid of this, which is in the center of that. You must have these two coordinate. This is y bar 2, and x bar 2 is 0, because you assume it is on the y-axis. Okay? You assume it is on the y-axis. Then x bar 2 is 0. What happened? For x bar, for the centroid that maybe the real centroid will be here, somewhere around this point here, is summation of what? I x bar I divided by summation of I. But here, instead of adding together, you must subtract area from each other. It means that AI for this, which is, we have a A2 here, anything 2, A2 x bar 2 minus A1 x bar 1. And this is A2 minus A1. Then we call it A2, we call it A1. This gives you the x distance from the centroid. It comes a little here and maybe over. That's the x bar, and that is the y bar. And what about y bar? For the centroid of the composite area is A2 minus A1 the same. A2 y bar 2 minus A1 y bar 1. Then you will find the centroid of this composite area. That's how to find out the centroid of a composite area, which is the cross section of a beam, for example. Thanks for watching. See you in the next video.